Hello everyone, my name is Saud. I will be the theoretical teacher for this course, Electrical Circuit 1. So before we start, let's make some arrangement. In terms of my details, you can go to the blackboard and click on the icon about the instructor and you will find the details there. The course semester plan will be provided later for you once it's signed by the chairman. Also, the class arrangement between me and you will be as the following. At the beginning of each week, I will upload 2 lectures for you, 2 lectures per week. Since it's a summer semester, the sessions will be duplicated. So instead of 1 in the normal semester, you will have 2. So I will upload 2 lectures for you. You can watch it. And the session will be conducted not for explaining, it's just for problem solving. So what you have to do is watch the lectures that is uploaded to you, prepare your questions, ask me at the beginning of our session, then we will go directly to the problem solving and clarify all the details to you. So let's get started. Everything in this world either existed as a single element, for example, gold, copper, so it's the pure version of the element, or consists of a combination of elements. For example, water, it has two atoms of hydrogen and 1 atom of oxygen. So what is atoms? Atoms is what forms the element. It consists of proton with a positive charge, neutron, and electron with a negative charge. The proton and the neutron will exist in the nucleus, while the electron orbiting around the nucleus. So, in a stable condition, the number of proton must equal the number of electron. To achieve the balance, they should be equal. Let's take the lithium as an example. Lithium has atomic number of 3. That means the number of proton is 3 and the number of electron is 3. They should be equal. But if not, what will happen? Then this element becomes an ion. So what is an ion? An ion is an element that lost or gain electron. So the same element, if it lost an electron, then for example, let's take the lithium, the number becomes 2 if it lost an electron. So the number of proton will be more than the number of electrons. That means the element becomes a positively charged. What if the element gain an electron? So instead of 3, it will be 4. What will happen? Then the element itself become negatively charged. Why? Because it has 1 extra electron. So it needs 1 electron to be removed from it to be in the stable condition, or to balance between the number of proton and the number of electrons. Now, how these electrons are existed around the nucleus? Let's take the electron configuration. The electron configuration, if this is the nucleus, okay, around the nucleus there is a shells where the electrons existed. These shells has a maximum number of accommodation. The first shell, for example here, it has a maximum of 2 electrons, the second shell 8, the third shell 18, and so on. For example, if we took the same element, the lithium, as I explained that the lithium has 3 number of electrons. Okay, the number of electrons are 3. So in the first shell it can accommodate a maximum of 2. Okay, then one electron will be left, so it will be placed in the second shell. Now the second shell has a maximum of 8, so 7 spots will be left in the second shell for the electron movement. So the electron can accommodate these slots and move to another atom. Now the electron movement. As I explained that the electrons are moving around the nucleus, and they are weakly attached to the atom's last shell only. This shell, for example, the last one. Okay. However, usually it can jump freely between one atom to another. So basically it has two movements: the natural move from one atom to another, and the net charge for this movement is 0. Why? Because one electron will be going to another atom in the last shell, and another electron will be coming to the same atoms but in different direction. So the net charge here will be 0. So one movement will cancel the other one. While as you can see here, while if we apply a force on these electrons to move it, it will have like an organized movement to one direction, and this what we call it the current. When we force the electron to move in one direction, we cause an electric current, and that's what defines the electricity. And this force, we call it the voltage. So basically, if we want to apply a general rules to know the conductivity of the material, the conductivity is how I can move an electron from one atom to another to cause an electric current. If I can't do that successfully, that means this element is a conductor. So there is a certain rules we have to know to distinguish between the elements, if it is conductor, insulator, and so on. Usually, for example, if you have, this is the nucleus, the lithium for example, and these are the shells. Once you go further from the nucleus, the less energy it needs to kick the electron out. So elements which has more shells and the electrons, okay, or the last shell is further than other atoms, like for example, if I have electrons here in the second shell and electrons here in the fourth shell, the amount of energy needed for this electron is way less than the amount of energy needed to kick the electron out from this shell. So this material will become a better conductor because I can control, or I need less energy to kick the electron out of its shell. Now, if the number of free slots in the shell is more, the better conductivity will be. So, for example, if I have the second shell can accommodate 8 electrons. If I have only 1 electrons here and 7 slots, okay, it will be a conductor, okay. But if I have another atoms, for example, that has 2 electrons in the last shell, it will be a conductor, but the first one is more conductive than the other one because of the free slots. So now, usually we take a look to the last shell. If the number of electrons is less than 4, the better conductor the element. If it is more than 4, the material is insulator, عازل. It will resist the electron movement, even though it has an empty slot. And we will see later, inshallah. If the number of electrons is 4, the material is a semiconductor. It should be exactly 4. So we can classify it either conductor, insulator, semiconductor. Conductor, it allows electron to move freely. For example, gold, copper, and we can see here that the last shell contain only 1 electron in the gold, and the last shell in the copper contain only 1 electron. But if I can ask you, which one is a better conductor, the gold or the copper? Definitely we will say the gold. Why? Because the electron here is placed in 1, 2, 3, 4, 5 in the 6th shell, while here is in the 4th shell. So the amount of energy needed to kick the electron out of the its shell is way less than this one. So a better conductor, the gold will be a better conductor. Now the insulator, as we can see here that the number of electrons in the last shell is 6, so it's more than 4. So this element, for example the sulfur, is an insulator. It resists the electron movement. Each insulator has a breakdown point. Once you reach it, you can convert this insulator to be a conductor. For example, الأير or الهواء, it needs 30 kilovolt to break down the insulator for the air, it needs 30 kilovolt to convert the air to be a conductor. And we can take the plug as an example. If we apply a 30, if the amount of charges or the potential difference in the sky reach 30,000 kilovolt, the air itself become a conductor, and we can see spark. The semiconductor, it needs certain condition to be a conductor. So usually it is an insulator, okay, or it can allow partially movement of electrons. When the temperature, for example, for some elements increase, it will be a conductor. So the semiconductor, depending on the condition, it will act either a semiconductor, insulator, or a conductor. For example, silicon. If we take the silicon and the solar cell, خلايا الشمسية, once the radiation hits the solar cell, the silicon becomes conductor, and it will conduct electricity. So basically, what is electricity? Electricity simply is movement of electron. If you can force electron to move in one direction, that's called electricity. It doesn't need to be one electron or one direction, but if we can force the electron to move, you are causing electrical current, and that's define the electricity. Now, what is the direction of movement? Now, as I told you, if we took, for example, the lithium, the positively charged lithium and the negatively charged lithium, you can see here that these atoms need an electron to achieve the balance. Positive, that means the number of electron is 3, proton is 3, and the number of electrons 2. Here, the number of proton is 3, the number of electrons is 4. Now, to achieve the balance, the direction for the electron should be from here to here. So this one will gain electron to be 3, and this will lose electron to be 3, and this atom will gain electron to be 3 and achieve the balance. So the direction naturally, or the real direction, is from negative to the positive. But what we are going to use is, to make it easy, we will assume that the movement is from the positive to the negative. We'll just reverse the direction, while the real direction is from negative to the positive. So from that concept, we can think of the battery. What is battery? Battery is the same thing. It's like two containers, okay, and a separator between them, fasil. We will fill this container with negatively charged elements and this one with positively charged element. Now the movement will be, let's take the real direction, it will be from here to here, okay? Now, if these are the terminals not connected, the electron here are trying to move to this direction to achieve the balance, but the separator will prevent that. So what will happen? It will remain as it is in the battery until you connect, for example, lamp. When you connect a lamp, the electron will move from here to here. The energy generated by the movement of electron can be used to do a work. For example, glow a bulb, or charge a mobile, or running electronic device. So whatever the application is, the movement of electron can generate an energy to do this work. So if we are talking the direction of the movement, as I explained before, it will exhibit only one direction, and that's why we call it direct current or DC, because it has only one movement from the negative to the positive. Now, is it unlimited? Of course not. Why? Because we have only certain electrons here to be transferred to fill the holes here. Once you achieve the balance, the battery will become a discharge. خلاص تصير فارغة. So what we are going to do, we have to connect this battery to an electricity. Why? To force the electron to, now once it's discharged, it is balanced. So no electrons need to be removed here, and no holes here need to be filled. When you connect this battery to electricity, you are forcing the electrons to move from here to go here. Once the process is complete, now the battery is charged. So charged, that means you force the electrons to be here, and you make a holes here in the positive side. And once you remove the electricity from the battery, now again the electrons want to go back to its position. How? By connecting a conductor between the two terminals. Once you connect it, the electron will move to go here. Now, if I bring a battery, these are the terminals, and I place a wood here. Wood is an insulator, عازل. What will happen? Nothing. Why? Because even though the electrons want to move, it cannot, because the wood is an insulator. It will not allow the movement of electron at all. That's why the battery will remain as it is. Now we can define the charge as this number of electrons. So one charge or one coulomb, okay, equals 6.24 to the power multiply 10 to the power 18 of electrons. So this is the number of electrons, okay, that's equal to one coulomb, and this is what defines the charge. The current, okay, is the number of electrons passing a specific point in 1 second. If you are standing here watching the number of electrons, okay, in 1 second, this is what defines the current. The unit is ampere, so the 1 ampere is equal 1 coulomb per second. So if you are standing here and you count this number of electrons passing in 1 second, that's mean you have 1 ampere. If you are counting half of this number, you are counting half an ampere only. So the unit of the current is ampere, the unit of charge is coulomb. Now, what is voltage? Voltage is what makes the charge moves. Now, if you look to this figure, okay, you will find that by creating a potential difference between the ground and the upper part, the water will flow. If we have a flat, for example, flat surface, the water cannot move. Why? Because the potential difference between this point and this point is 0. The same will be applied to the electricity. We have to create a potential difference between the positive side and the negative side, so the electron moves. You can see here that by the movement of water, we can rotate this wheel, right? So we are benefiting from the water flowing by rotating the wheel. The same thing will be applied here. By the movement of electrons, okay, we can benefit from this movement by producing, for example, light, heat, charging mobile, whatever the application it is. Since the movement of electron produce energy, we can benefit from this energy. So the flow of electrons, okay, is governed by a resistance. So the resistance can control the amount of electrons. And we can see here, if we have a small cross section here, the amount of water flowing will be less. The same thing will be applied here. If the resistance is high, مقاومة عالية, less electrons will flow, that means less current will flow. If the resistance is low, قليلة, more electrons will flow. So the resistance, the equation of the resistance will be known by this equation. The resistivity of the material itself multiply the length divided by the area. So the material itself, if it is copper, aluminum, gold, whatever it is, it has a resistivity, fixed number, okay? We can multiply this fixed number by the length of the material and divide it by the area. So if the length increase, the total resistance will increase because it's a multiplication and it will increase the resistivity or the resistance, the total resistance. If the cross section of the element increase, that means the less resistance will be. So the length will increase the resistance, the increment of the length will increase the resistance, and the increasing of the cross section of the material itself will decrease the total resistance. Now, what is Ohm's law? Just in general. So this is the real. For example, let's consider this a bulb. Okay, the battery will be connected to a bulb and the bulb will glow. Now we are creating a potential difference between this terminal and this terminal. Okay, this is 0 voltage, this is 12 voltage, so the difference between them is 12 volt, and that's what will define the battery. And the current now will start moving from this terminal to this terminal to make a balance. During the movement, the lamp will glow. Now if we want to create to convert this drawing to say a circuit, we can just draw the symbols of the battery, symbol of the bulb, okay, and the wire. Then we will end up with circuit, and this is what we will study, the electrical circuit, this one. So the battery has a symbol connected to a wire to a bulb, and this is a switch. Now we can control, or we can study or analyze the circuit. 0, 12, for example, the battery is 12 volt, the lamp, for example, has a resistance. We can calculate the amount of current by using Ohm's law. Ohm's law states that the voltage here is equal to the current multiplied by the resistance. If we have a resistance here, for example 2 ohm, we will study that later, and this is 12 voltage, and we want to know the amount of current here, we can just rearrange the equation to I equal V over R 12 over 2, so the current will be 6 ampere. Thank you so much for listening. As I have explained to you, I will upload 2 lectures per week. You have to watch these lectures prior to your session. Then at the beginning of the session you can ask me any question, so I can clarify the concept of the things that you didn't understand during the lecture or during the recorded lecture. Then we will start exploring the examples or the problems during the session. Thank you again.